Hey guys, this is video 9 in Unit 4 on ionization energy. So we're going to continue with our fourth trend here. We will be on page 21. And this is a big one. So really all of these trends are big. I keep saying that with every video, but they're all really big. You got to know them. And the only way to know it, guys, is to really go through and know the terminology, okay? This is a very conceptual unit, not a lot of math. So you've got to know your terminology. Very, very conceptual. So lots of practice, lots of asking questions. That's the way you're going to be successful here within this unit and then through the rest of the year. So ionization energy, I call it IE. Kind of abbreviate it a little bit, so you don't have to write the whole word out. Now, just if you break it down, ionization energy. So ionization meaning ion, so it's the energy that's needed to remove the most loosely bound electron from an atom or ion in the gas phase. Values for each element is again listed in table S, much like a lot of the other trends that we're talking about here. So really just excuse me, keep it simple. It's the amount of energy it takes to form an ion. That's what ionization energy is. So think about elements, okay? They are stingy with their electrons, meaning they want to hold on to them, kind of like Scrooge with his money, right? So if you have X plus energy, then you're going to have X plus an electron would be taken off. So these are losing electrons here. So you're trying to remove an electron. Now, if you think, with all the trends that we've already talked about, do they all want to lose electrons? The answer is no, right? Because we've said in past videos and in other parts of our notes that as you move from left to right, the number of valence electrons increase, so you get closer and closer to the magic number of 8. So if you're thinking to yourself, hey, is it going to be easy to remove something from like fluorine or even a noble gas? The answer is no. They're closer to 8. They don't want to lose their electrons. They want to hold on to them. So you're absolutely right, and that's what we're going to see here. So as we go from left to right, this is your big one. Okay, so notice this trend, the horizontal trend here, is more important with ionization energy, just like electronegativity. That value, or I'm sorry, that trend, the horizontal one, is more important to electronegativity. So as we go across a period, ionization energy is going to increase. The reason for that, much like electronegativity, you've got an increased nuclear charge, meaning those positive protons are going to pull on those negative electrons. They're going to try to keep them close to them. They don't want to let them go. All right, so your number of energy levels or your shielding does not increase. Same as electronegativity. So these two trends are very, very similar. Okay. So here's kind of a picture with values. And again, these values are in table S. You guys are going to, if you haven't done so already, you're going to be graphing them in your lab number 12. So here we go. How you see a typical chart like this, and you could see one on the Regents exam, they point out the noble gases. Why do you think they're going to be the highest? Well, noble gases are stable. Their outer shell has got a full octet, except for helium. Helium has 2, but it's still, first energy level only holds 2, so they're stable. They don't want to give them up. They will fight tooth and nail to hold on to their electrons. So it's going to take a lot of energy to remove those. Where if you look down here, lithium, sodium, potassium, rubidium, cesium, francium, they're the alkali metals. They only have 1 valence electron. They're easily going to give it up. It's not going to take a lot of energy to pull those outer electrons off of them. So we kind of see that here, and this could be, again, something you could see, a chart like this on the Regents exam, and kind of have to explain the why. So make sure as you go throughout this and you're answering your questions in practice, make sure you know the why behind it. That's what you've got to do. Know the trends, but you've got to be able to explain the why. Okay, it's another reason why our alkali metals here, as we saw in the video on the alkali metals, it's why they're so reactive, because they're readily giving up their electron. They're going to react very violently to just let it go and form a stable octet. So that's your big one. Okay, your horizontal trend, that's the important one. So I'm going to highlight that like I've done before. Going across a period, that's your most important trend. Okay, that's the one that's going to impact things more so than your group trend. So as you go down a group, ionization energy is going to decrease. Okay, the reason behind that, same as electronegativity. Your energy level is going to increase. Okay, you're gaining a new orbit, a new row around your nucleus, so you're getting further and further from it. Oops, spelled that wrong. Okay. Again, same as before. The farther you get from your nucleus, which is that positive charge trying to pull in those negative electrons, it gets easier to remove. So think about it like this. As you grow up, right? As you're a kid, toddler, you're right by your parents' side. They have a lot of control over you. As you get older, you get further and further away. It's easier for you to kind of do your own thing the further away you get. When kids go to college, right, they can do their own thing because they're not by their parents' side anymore. Good and bad with that, but that's for a different video. So the way you want to think about, guys, is like magnets, okay, meaning the further from the protons your electrons get, the easier it is to remove them. So as your energy level increases, you're further from the proton, meaning it's going to be easier. So if you think about magnets, okay, the further you get from one magnet to another, the easier it is to kind of manipulate them and move around. But when you get them close together, that's where it's very, they get much stronger. So just to recap, kind of summarizing it, your number one trend, okay, is your horizontal trend. So your period trend, so left to right, is more important. And then would be your number one. And then number two is going to be your group, so top to bottom. Okay, so left to right, it increases. And then top to bottom, it decreases. This is just very similar to electronegativity. You can see that pattern kind of start to unfold.